Everyone, welcome to another section of the Terminalian AI Data Science Introduction to Data Science course, and we will be dealing with Python data science ecosystem and libraries. And what we'll be looking at in this section is how to install Python packages with the use of pip, and also you will be introduced to Numpy. You will be introduced to how to be able to manipulate data, numerical data, with the help of Numpy, the package called Numpy. Also, you'll be able to see how to carry out mathematical functions, mathematical manipulations, mathematical calculations like linear algebra, like simple mathematical operations, the addition, the division, the multiplication, the subtraction, and a minimum, maximum of a particular set of numbers. So that's we are diving into statistics, looking at the cumulative at the sum of a particular group of numbers. We are also be looking at how to do how to use Pandas. That's also another package, very popular package in data science, and we'll be introducing you to data structures like a series, an array, and data frame, and also we'll be taking you through how to undo missing data in Python, and how to do groupings and aggregations. We'll also do a little of exploratory data analysis, and this will all be very surface, just bringing you into the limelight of data science. And at the end of this lecture, you should be able to try your hands on one of these particular tools, and we'll also give you links and show you an easy way to be able to carry out all these things and even dive deeper into what we've not looked at. So thank you very much. Let's move straight away into what we'll be having. So first of all, we'll be installing data science libraries, and there is a particular package management system called pip, which is used to install packages, and packages are a group of modules that also has an init.py file attached to it. A Python package is a folder or a directory that is made up of modules, and the modules are Python scripts that can be used in not just only in one Python script, but it can be imported in other Python scripts as well. So a package, is modules that also has an init.py file attached to it. So it is, and the init.file is written this way: init.py, and you don't need to bother yourself with the reason or the syntax of this. When you get to classes and modules, you know more about that. But for now, don't bother yourself with such headache if it's giving you a problem. So let's go straight into our let's go straight to our let's go straight to our let's go straight to what we have for today. So in installing a particular Python package, for instance, Pandas is a Python package. Pandas is used to do data wrangling, is used to do data cleaning, exploratory data analysis. It is the Excel of Python, let me put it that way. And we also have Numpy, which is like the Matlab of Python, in quotes, the mathematical aspect of Matlab in Python. And we have Seaborn, which is also like Seaborn and Matplotlib, which are the graph aspect of MATLAB in Python. And we have scikit-learn, which is also a machine learning module, and which is usually more of for educational purpose. We have Beautiful Soup, which is used for the web scraping the web for scraping data from the web. And we have TensorFlow, which is used for deep learning. So when you do pip install, and you can just write all of them once, it runs, and that's all. It's been downloaded. That's just it. And once you have this in your computer, you can run this from the command line. But actually, you see this, we have an exclamation mark here, and normally in an IPython environment, the exclamation marks makes you to communicate with terminal. So it runs anything you put an exclamation mark first as a terminal command. Just like the way it runs in Python, it runs anything you put the hash symbol first as a comment. And a comment in Python is, or in any programming language, is something that you add. Those are lines of codes or lines of sentences or instructions written that should not be executed. So the Python compiler sees that hash as something that should not be run, should be ignored when running the program or the script. So now let's look at Numpy and the ND array. So Numpy is a library, as I said, that work with arrays, and arrays are kind of list, but this one, they are faster in terms of manipulation, in terms of computation, and in terms of flexibility when doing mathematical computations. Arrays are far faster than lists, and they have a lot of computational, in terms of being able to easily compute digits, compute numbers, compute lists, like being able to run mathematical computations on the list of numbers within the square brackets. So arrays, how are arrays represented? A very good example here is this precipitation problem that is being given, and we use Numpy to be able to manipulate through some data on precipitation. So what do we do first? When you have installed a particular Python package with a pip install, what you do next is that, by the way, remember I said packages are groups of modules, and modules are functions that can be imported from that can be imported into any other programming, any other script, to be able to perform a particular function. So and packages are groups of modules that have been separated or grouped and an init.py script is added to it, or to the directory, to be able to make it run as a standalone or as one group of modules. And so as you import Numpy, it means you have imported all the notebook, all the modules in the Numpy library, and we are importing it as np just to shorten it, because there are some packages that have long names. So that means anywhere you see np, it means it is Numpy that is there. So as we see np here, it means it is Numpy here, here, and here, and as you go down, when you see them. So now we give ourselves a group of figures for precipitation, average monthly precipitation, for monthly average precipitation from January through to June in Boulder. That's a town, Boulder, Colorado, I guess. And we have also given an average monthly precipitation to, that's the variable name, to be a group of arrays that an array that have figures of average monthly precipitation from July to December. And we said it should print this true. It should print the average precipitation from July through to December. It's also supposed to print from January through to June, and that will be average precipitation. And we are also telling it to add both both arrays. That's adding together every average precipitation in each arrays. So always look at arrays as lists. They come in form of lists, but when you look at their data type, it will tell you it is an empty array. That is an array. So when you add them, it gives you a value. And also, we're now also going to look at the difference. That means the second one, the average monthly precip 2, be subtracted from the average monthly precip. So that be 0.70 minus 0.87. Now the first one, which is the element wise sum, means 0.70 in average monthly precip. That's the one with the index 0. Will be added to the index 0 of average monthly precip 2. That's what this element wise sum for both array will give. Now, and these are all special functions that can be found in the Numpy library or Numpy package. Then in terms of multiplication, you can also do that. np.multiply. You can even use the normal avg times avg monthly precip. It will give you the same thing. Here, let me write that code here. So that will be print. Let's Control C and put it here. And instead of doing np.multiply, I can just do this times precip times this. and it will give you the same thing with the above that it's supposed to give you. Perhaps when we run the file, when we run the script or the cell, any error we get, we'll go and fix it later. So next one is the division. The division can also be written as this. Sorry. And the square root can be left that way. Yes, there is no short way of writing the square root. Just have to give it this way. So let's run this and let's see what it gives us. So see, the multiplication is the same, the division is the same, and that's all. Even we can even do that for the addition and the subtraction. So when we come here, we can do that for this. So they are basically the same thing. Remove this, give it this way, and remove this. Put it this way. Do this. I think let's run this again and let's see how it goes. There's an error. I don't know. Okay, I have multiple columns there. Okay, I didn't correct this. I should do this. Oh, sorry. Yes, and I should remove this. Yes. Okay, let's run this cell again. What's the error? Problem must be C, Ctrl V. I'm removing this, and I'm removing this. I'm putting this, and I'm also doing the same for addition. C, Ctrl V, removing this. Okay, let's try this. Let's try to make our code neat. Yes, let's try run it again and let's see how it goes. So it has run. There were no errors there. So that elements wide sum were the same, even though I used different approach. Element wise different, the same. Multiplication the same, division the same. For square root, I guess it's only that particular way of writing. Now let's move to that's it for the mathematical manipulations, the basic mathematical manipulations. Now we are moving to aggregate the aggregator function. Now we want to print array-wise sum, and here the aggregator functions is just looking at the sum, the mean and the max, and the cumulative sum, the mean, the median, the mode, and all that. You can use Numpy to do all those statistical um, operations. And when we run this cell, it gave this. We can even go ahead to add print Control C, Control V. Let's see if variance will work. Although I've not really taken a very good look at the data to see if variance will work. But let's see. VAR. Let's run it again. Yes, it worked. When trying to look for quick references, the official reference note is a very good place to go to. Yes, Stack Overflow is good. Other communities are good to ask questions, but things like this, it's a very good thing to go through the original references. It's going to help. It's really going to help a lot. So now, for statistics, let's look at mode. We have median here, numpy.median, even the percentile, quantile. We have the mean variance, non-mean, non-median, non-variance. When we look at the non-median, what is it? Compute the median along the specific axis while ignoring nons. Are you seeing? So it's return the median of the array element, and it gives a brief, a very detailed explanation of what every possible thing you can do with the median function. Non-median, it can use every possible thing you can do is given. Every possible instances in which the non-median can be used is given. But I'm looking for mode, and it appears that mode seems not to be there. Let's go back. Mode seems not to be there. So mode seems not to be there, and but median, yes, numpy.median is there. Let's go to see what it will give us, and that's it. So it's a very, and let's try non-median. Let's try non-median. It will be the same if we have no non value in the array. Yes. And let's play that, and that's it. It's the same thing. Now, so let's look at subscripting and slicing. So a very good characteristic of NumPy is the way you can easily manipulate, slice, and access the numerical data, numbers in the array. It is very nice. It's just like matrices and vectors in Matlab and Octave. If you are familiar with those types of softwares, yes, it's similar here, just with a little bit of different syntax. So let's look at this. Let's look at average monthly precip. Let's look at what it will give us. Control Z, sorry. Control C. And let's see what it will give us. Oh, sorry. So this is the array. This is it. And we want to look at from index. So what we see in this square brackets are the indexes. So when I'm saying 1:4, it means from index 1 up to index 3. So that means index 4 in the array, index 4 will not be selected. Rather, index 3 will be selected. And when we run it, you can even see from here, it is from index 1 to index 3. So now, and the indexing is from 0 to infinity, or to how far your memory can carry you. So now we have index 0, which is 0.7, index 1, which is 0.75, index 2, which is 0.18, which is also here, and index 3, which is 1.97. But index 4, no. That is the rule, that is the way Numpy is being programmed. And now when we look at index 1, it brings out 0.75. There is a whole lot of things you can do. You see, there are a lot of subsettings, a lot of slicing operations you can do, even with multiple dimensional arrays. There are a whole lot of things you can do with them. This is an example here. It said print from index 0 to 1. It printed 0.7, 0.75. Print any average monthly precipitation. Print out average monthly precipitation, precip. And in the square bracket, you can also impute a particular condition. That's where, so you like the square bracket is like where, like feed me back with the values of the average, the values of the variable average monthly precipitation, where average monthly precipitation is less than 0.6, and we add none. So let's try another one. So if we decide to use the parenthesis, look at what it will give us. Sorry. Oh, sorry. Let's see how this goes. Oh. Okay. np.all. Let me do this rather. And let's see what it gives. It's going to give false for this. False for this. And let's see the reference library, the reference website, sorry. And we can check out for other functions that can be used in an array, and these are all functions that can be used, and these are the list of subsections over here that can be used. But normally this will be what as data scientists you'll be using most of the time. This. And the routines, yes, that's what we'll be using most of the time. Creating and manipulating through the Python library. Even for linear algebra, these are things you can use This is for determinant, engine values, and engine vectors, engine values of a general matrix, inverse of a matrix, the least squares solutions of a matrix, a normal, a vector norm, and you can even solve a linear equation, matrix equation, and a singular value decomposition. A whole lot of things you can do through with Numpy. But for your level for data science, I think routines, and perhaps from routines are the major ones you'll be using. Routines are the major ones you'll be using. Yes. So we can also, there is also a way of getting this. I got this from the reference. Everything it's just when you go to the reference, it's a more authentic way of getting the right thing done. When you are stuck somewhere and you need to get through it, you go to the reference, and after it is when you've gone to the reference and it doesn't still make sense, then you now go to a community. That's all I would advise you to do. You now go to a community to try and ask more questions on how this can be solved. And so for instance, I went to the online reference for Numpy, the official online reference for Numpy. I copied this and I pasted it here, and I just filled it with the ones I desired. I took the data type, filled it with the shape I want and the value I want, and this is what it creates. So it makes this particular function np.full allows you to use one to fill a particular array with a figure, a number. If I make this float 32 or float 16, float 32 is going to give me a float. I think that's dot. If I make this a 3x3 matrix or array, it's going to give me a 3x3 array. Sorry, but this is a two-dimensional array actually, but it is a two-dimensional array. That's 2 by, let's try a three-dimensional array. And let's see this, and this is a three-dimensional array, and this is an example of a one-dimensional array. This is the structure. A two-dimensional array is a matrix, and a three-dimensional array is like a cube, and that's actually how it's been done in Numpy. So that's all for Numpy. There are more. I would advise that you go through just the routines. Yes, that is where you will need more of it. Yes, when you focus just on the routines, you will be abreast with most of the things that will be needed for data science. Yes, creating a random array. That's when we can assign rand array to np. We can assign a random array to rand array, and how to generate an random array is np.random.randint. Randint makes it an integer, but if you just make it rand, let me give an instance. So we have np.random.rand, and this, let's make it a 4x6. Let's see how it goes. Oh, sorry, I made print capital letter. 4 by 6 rather, sorry. And we can see this 4 by 6 array here. This is 4 by 6. So the 0 axis, the axis 0 is the vertical axis, and the axis 1 is the horizontal axis. So this is how to make a random array. Well, let's make a random int. A rand int. Yes, a rand int array, and that will be equals to np dot rand int, and here you have to specify. Let's go check it up in the reference. So what do? Come to rand int here, and this is the syntax. This is how it's supposed to be written. So rand 8 int, we have the maximum and the minimum and the maximum. The low is the lowest integers to be drawn from the distribution. So that's the lowest number to be seen in the particular array you want to construct and or create, and the highest number you want to also see in the array you are creating, and the size that's, is it a 4 by 6 array? Is it a 4 by 6 by 2? Is it a one-dimensional? Is it two-dimensional? Is it three-dimensional? And the data type you want to use. Once you said run int, you can make it the data type integer. It's integer by default. I don't think you can change it. Can you? Let's check this. The default value is integer, but I think it can be changed. And that's all. Let's check out this goes. So with that, we know this is the lowest value. Let's say we want 0. We want 0. The highest value we want 5, or let's just leave it that way. And the shape, let's make it a 6 by 6. A 6 by 6 integer, and let's print that out. A 6 by 6 array, and let's print that out. Let's print out rand int array, and let's see how that goes. What are they saying? Rand int array mode do Numpy has not rand. Sorry, random. Yes, random. Let's run it again, and voila, this is it. So we said we want a 6 by 6, so this is 1 2 3 4 5. 1 2 3 4. No, this is a matrix. What's going on? It didn't print. It didn't print this. Okay, let me give you the maximum 5. Let's see. Okay, let's see if something. Oh, okay. Okay, I hope we are seeing what's going on here, because I didn't give it any maximum. It gave a null matrix, a null array, so that means it didn't produce any random integer variable. If we run it again, since it is random, it will keep to change. If we run it again, to change and to keep changing. Oh, sorry, this. If we run it again, it will change. If we run it again, it will change. Oh, sorry. Yeah, it will change. That's it. And now we want to see average monthly pressure equals to this, and the average monthly pressure is equals to this. Now, if we bring them together, we can do that by doing concatenation. When we bring them together and we print them, we get this, and from there we can now convert it to be a matrix. Let's run this cell and see what I'm talking about. It's supposed to print two values. Yes, it has printed two values. So when it is being concatenated, it's supposed to print out 1 2 3 4 5 6 7 8 9 10 11 12. So exactly. So when you concatenate them, you can convert them to be a matrix. But now there is something we can do. Instead of concatenating, we can do vertical stacking. Concatenation is like horizontal stacking. So to do vertical stacking, no, let me do it before. Yes, so vertical stacking. I think that'll be np dot vstack. Yes, then into brackets you put both, and that will be as you can see, this is just very nice a very nice tool to use, the Colab. It gives you this convenience to know more. So over here we can put obstructing me this particular, so I don't need to put this. We can fix this in there, and let's see what we get. V, and then let's try to make this okay. Oh, sorry. Let's run it and let's all get wonderful. So this is what we have gotten, and that's just one other way you can also do. So instead of using concatenation, you can also even use horizontal stacking. And okay, let's name this V vertical, and we give this next one and we change this to print this horizontal, and change this to horizontal, horizontal, and this is where the magic is. From the V stack you change it to H stack, and let's print this, and we can see this is the V stack. In fact, let me make some notes there so it will be easy for us to see. So vertical stacking equals this horizontal stacking horizontal stacking equals this, and matrix equals this. So let's run this and let's see what we get. Error. Oh, sorry, no comma here. No comma here. So let's give it another try, and voila, that's it. So this is the matrix, this is the horizontal stacking, and that's the vertical stacking. So I think that should be all for. Okay, now we go to the for linear algebra. So to solve for linear algebra, it will be better to use a verified question. So I took an example from the linear algebra reference over here for us to run it and see how it works, because when you try to use a matrix that has not been tested, the possibility of getting an error is there. So let me paste this. Now we have A to be an array, which is this. So A, we have B, and we have X. Now X will just be solved because we've imported Numpy from numpy.linealg. We've imported solve, and so when we press enter, we have to get this. So this is the this is X in the equation AXB. Now I want us to see how A and B look like. So let me print A and also print B. See how it looks like. And this is A, it's a 2 by 2 matrix. And this is B. B is a 1 by 2 matrix or array. Yes, let's use the array. So let's go through Pandas. Pandas is a Python package that is used to do data wrangling and also used to display data in data frames. And a data frame is a couple of series coming together to become one. And a series is made up of a title or a header, and then a column index, an index column, and then the data. So this is a data frame. It contains a column, an index label, and in each column and index, column and row, we have the values in them, and we have non-values, which are missing values. We have data in different formats. We have, this is string format. This is also string format. This is float format. This is perhaps it should be string. I guess it's a string because of this hyphen sign here. And we have float format, we have string format, we have float format. So these are the data in it. This is called the index, and it is axis 0. So the vertical axis is the axis 0, and the horizontal axis is the axis 1. And we call these column names. Yes, and so when dealing with Pandas, all you do is import Pandas as PD, and in Pandas you need Numpy to do a lot of calculations. You know, when you're doing data science, when you are doing exploratory data analysis, you need to know your data. You do what we have univariate analysis, we have bivariate analysis, we have trivariate analysis, we have multivariate analysis, and you try to do all this analysis to understand your data. For instance, you look at this name. Are there any missing data in name? Are there single names or double names? Are there space between the names? There is a way you can check this. So you can pick that out, this name as a series, and try to manipulate through it. Try to see the popular names that are there, and even to see if there are repetitions of names, repetitions of data in that particular in any particular set of rows, and you have to delete if there is a need to delete some of these particular rows or these particular columns. Perhaps we may have age twice, which you know that the second age is not needed. For instance, this height that is 6'2", what does the 6'2" mean? You need to understand it. How can you convert it to a more understandable or a more to a better format that you can use to make proper analysis? The weight, is it in grams, is it in kilograms, is it in pounds? All those things you are trying to, that is what you do in data exploratory data analysis to be able to understand the salary. Is it in dollars? Is it in naira? Is it in cedis? Is it in pound sterling? Is it in Australian dollars? Is it in rupees? Just look at it. And you can also see when it comes to teams, you can check how many unique teams do we have. Is it only Boston Celtics, or do we have Lakers there? That's what we can also do with these Pandas and Numpy together. And Matplotlib, in Matplotlib you use Matplotlib to visualize some the data and see and try to see some trends in them. These are things you can do. Now let's look at this this cell here. Say average monthly precipitation is, they are converting this particular precipitation from, so now you see they are converting it from just mere list to data frame. Yes, they are converting from list to data frame, and look at how it is being done. And when you run this and you key in your average monthly precipitation, try to get the output, you get this. It's been converted to a data frame, and you can see that in data frame it displays the data in form of Excel sort of. You can see this is rather the data. So data type of object, it's an object. Yeah. And this, you see, V, or press in rather, and let's see. It floats. Yes. So you notice that this January here is not it's not a string, it's an object rather. An object is also a special data type in Pandas. So how do we manipulate the data? If you want to look at null values, yes, so you can do that is not this. But me, instead of doing this, I prefer to do this. Ctrl C, Ctrl V. That's some. Let me see. Yes, this is what I love to do, and it gives you for every column. For every column, it gives you this. So the months have 0 null value, and the precip in that the precipitation has 0 value, and the data type for this is 0, is in integers. Now, so let's do a little bit of data and exploratory data analysis, which is shortened as EDA. So you can want to do header 5 tail 5. So the header, what the header 5 does is it prints out the first five values, and this is what we have. Let me do this print rather. Print this print this, print this, print this, and let me leave this, or I should print this. Let's go. So we have this. So this is the first 5 value of the columns and the rows, and this is the last 5 values of the columns and the rows according to say print the tail. And when you say print dash.info, it gives you a brief summary of the table. And as you can see, it says the range index is 12 entries, 0 to 11. Then no null value, non-null value 12, null value 12. Data type is object and float, and everything here is made up of object and float. That's the information given here, and the memory used is this byte. And the last thing to be said is .describe. So it gives a statistical information. The .describe gives statistical information of the .describe gives a statistical information of what you have for numerical data, but it does not give statistical information for object or strings, or I'm not sure for Boolean. I'm not sure it gives for Boolean. Now we move to something else, plots, and that will be the last thing we'll do. And for pandas, just when you just type pandas, you can see the more information on pandas. I think I was looking for something and it brought out pandas. I just love using the reference point, although yes, it might not be straightforward sometimes, but I will advise you go there first. So if you just type pandas, that's all it comes. If you type matplotlib, matplotlib, I believe in this page. It brings this. So you can just come here, the official site, and get information from it about reference, cheat sheet, a lot of things you can get from here. Even Seaborn, you can get Seaborn from here also. So from here, f comma ax equals plot.subplot. Yes. So when you come here and you get started or reference point, let's go to get started. Now you import matplotlib as matplotlib.pyplot as plt and numpy as np, and you can go. When you're using Jupyter Notebook, you have to put something like this matplotlib inline yes, you run it. Yes, I guess I'm right. And in plot any type of plot you want, and they give detailed explanation on what to do. Well, let's go to our lecture for the day. So what did we do with what we got from our example? Average monthly precipitation is dot plot, and you give your detailed information. You can say this because over here you have a data frame that is called average monthly precipitation. So, and Matplotlib is inbuilt into Pandas. So it's like you are saying df.plot. Then you said the x-axis is this, the y-axis is this, and the title is this. And ax is the axis. Is it axis? Yes, axis. I think I saw it here. Not quite long. Yes. This is it. The axis. Yes. And so ax equals ax. And plot.show brings this out for the precipitation from January to December. But see, it skips, in part because of space, it skips some of the months. Like you could see that December is here, you could see that February is here, you could see that this is March, you could see that this is April, you could see that this is May, this is June, July, August, September, October, November, December. So that's how it is. May, June, March can be perhaps here. Oh no, so this should be April, should be May, should be June, should be July, should be August, September, October, November, and give you a legend. So that's just a simple way to do plotting in Matplotlib. There are other ways. We can try your hands on them. You can also come here and do a PyPlot tutorial, and they take you through plt.plot this, and plt.ylabel, plt.shows, and it's plot. plt.plot, and there's a way you can plot. There's a way you can plot histogram and bar chart. Over here we have plt.scatter. So when you use plt.scatter, you give the data A and B and C and D.